that's plus 1. And I have AR plus 2, x is to the power of r, plus whatever I have here, minus the same thing I have here, plus the same thing I have here, right? So since we have this, now considering this, check this out clearly. You have the limit for this one is I'll start from 0 to infinity. The limit for this one, for the term I have here, is I'll start from 2 to infinity. And here it is I'll start from 1 to infinity. And here it is I'll start from 0 to infinity. Among all these values for r, which one is the highest? The highest range for r start from 2. I'll start from 2. This is the highest. So I can decide to evaluate when r is 1, such that the next evaluation should be when r start from 2, so that it will end up meeting up with this. And at the same time, I'll evaluate r here when r is 0, and I'll evaluate that when r is 1, so that the next evaluation should be when r start from 2 to infinity. And I'll do the same thing for this. So this is what I'm trying to say. Here in this case, here in this case, I have to evaluate at when r starts from 0, at when r equals to 0, and at when r equals to 1. So I don't need to evaluate at when r is equals to 2, because I already have 2 to infinity, so I can easily factor out r start from 2 to infinity. So here in this case, evaluate at when r equals to 0. Like trying to solve this summation, set out to be equals to 0. I have 2, 0. I have 0 plus 1, I have 1. So wherever I see, I'll just put 0. I have a0 plus that's a2. Then x is to the power of r is what? 0, right? Then evaluate at when r equals to 1. The same thing. 1 plus 2 is 3. 1 plus 1 is 2. Then I have 1 plus 2 is 3. Then x is to the power of 1. Okay? So then the next thing should be plus. This term here is for the evaluation at when r equals to 0. The term I have here is the evaluation at when r equals to 1. So I don't need to evaluate for when r equals to 2. I'll just take it from 2, then end at infinity. It keeps on going. So I actually stop here because I want this to look like the next term I have here, and I want this to meet up with this to meet up with this. Okay, I did not repeat it here. So when r start from 2 to infinity, I'll have r plus 2, r plus 1, ar plus 2, x is power of r. You get that point now? So this is for all this expression I have here. Successfully I have this. Then the next term plus whatever I have here now is what I'm seeing here, which is what? Summation r start from 2 to infinity of r minus 1 of ar xr, right? So now it's clearly seen that xr is common. This summation, the limit for the summation is also common. The summation is common, so I don't have any issue with that. Minus the next term I have here is what I'm seeing here. So I need to evaluate this also. I need to evaluate when r is 1 and evaluate at when r is what? And I don't need to evaluate at when r is 2. So here in this case, open a bracket. When you evaluate at when r is 1, I should have 4 times 1. That's 4. Then a1 x is to the power of what? 1. Because I have r start from 1. Then plus the next summation. Do I need to evaluate at when r equals to 2? No. Just end it with r start from what? 2 to infinity of 4r, the same expression you have there, ar xr. Then what? You close the bracket. So it is clearly seen that I have this term, and this term. I can easily factor out xr and the summation, so it's making sense. So the simplification is making sense a little bit. Then for the last part, which is this, which is plus summation of r start from 0 to infinity. Here in this case now, you have to be very careful. You have to evaluate at when r equals to 0, when r equals to 1, but you don't need to evaluate at when r equals to 2. Do you get that point now? So here in this case now, I have when r equals to 0, then that means automatically speaking, open a bracket, I will end up having 6a0 when r is 0, x is power of, put when r is 0, 0. Then plus, evaluate at when r equals to 1. That's 6a1.